Polynomial inequalities. Solve the polynomial inequality and graph the solution set on a real number line. Express the solution set in interval notation. Here we have a polynomial inequality, and the first step to solving these inequalities is to rewrite the inequality with an equal sign. So this will be 5x squared plus 18x equals 8. Next, we want to set the equation equal to 0. So we're going to subtract 8 from both sides. And we have 5x squared plus 18x minus 8 equals 0. Our second step is to factor the polynomial. So we have 5x squared plus 18x minus 8. And we're factoring this so we can solve for x. Now this is a quadratic equation. You could put this in the quadratic formula and solve for x, or we can factor it into two sets of binomials, which we'll do here. Remember, to figure out what goes first in each parenthesis, we're going to look at the 5. The factors of 5 are 1 times 5 and 5 times 1. Next, we'll look at the factors of the constant term, which is 8. So that's 1 times 8 and 2 times 4. Now we want to pick a combination of pairs that when added or subtracted give us the 18x in the middle term. This is going to be a 5x and an x, and then a negative 2 and a positive 4. We can check this by multiplying the last terms together, and we get a 20x, and then the middle terms together gives us a negative 2. So negative 2 plus positive 20 will give us the middle term of 18x. So we know that we have the correct factors. Now we're going to set each factor equal to 0 and solve for x. For the first factor, we'll add 2 to both sides, and we get 5x equals 2. Next, we'll divide both sides by 5, and x equals 2/5. With the second factor, we'll subtract 4 on both sides, and we have x equals negative 4. These are called our boundary points of the inequality. We'll place the boundary points on a number line. This will help us create the intervals that we will test in our inequality. So the first interval is going to be negative infinity to negative 4. Now I'm putting parentheses by the negative 4 because our inequality had a less than sign in it. Since there wasn't an equal to line underneath that inequality sign, that means that the boundary point is not included, so I put parentheses around it. The next interval is from negative 4 to 2/5. And then the last interval is 2/5 to positive infinity. Now we're going to test each interval by choosing a value within the interval and then plugging it into the original inequality. So first I have negative infinity to negative 4, and I'm going to choose x equals negative 5. You can choose whatever number within that interval that you want. So 5 times negative 5 squared plus 18 times negative 5 is less than 8. This gives us 5 times 25 minus 90 is less than 8, which is 125 minus 90 is less than 8. Now that equals 35 is less than 8. Now 35 is less than 8 is not a true statement, so that interval will not be a part of our solution. Now I'm going to go to the next interval, which is negative 4 to 2/5, and I'll choose x equals 0. I just plugged a 0 wherever I saw an x in the original inequality, and when we simplify this, we get 5 times 0 plus 0 is less than 8, which is 0 plus 0, and we have 0 is less than 8. That is a true statement, so that means that negative 4 to 2/5 is a part of our solution. My third interval is 2/5 to positive infinity, and I'm going to choose x equals 1. So I'll plug in a 1 wherever I see an x in the original inequality, and when I simplify this, I get 5 times 1 plus 18 is less than 8, which is 5 plus 18 is less than 8, and my last calculation is 5 plus 8, which is 23, so I have 23 is less than 8. Now this is not a true statement, so that interval will not be in my solution set. The only interval that worked in my original inequality was negative 4 to 2/5, so my answer is negative 4 to 2/5. And remember, I have parentheses around each of these numbers because they're not included in my solution.